Okay, we're on page 4 of the notes here. This is the Practice Plus section, so it's kind of combining some things that we've done, some skills together. This is actually one of my favorite things to cover because it's one of those times where you can make one of those really great discoveries. But let's walk it through and see what happens here as we follow the directions and practice finding the vertex for the parabola. That's what the instructions say. Find the vertex for the parabola by first writing the equation in the form y equals ax squared plus bx plus c. Up till now, they've handed it to us in standard form. Where it's y equals ax squared plus bx plus c. Now they're giving it to us in a form that is not as familiar. We've seen it before when we've had to solve in earlier sections, and what we had to do was we had to go ahead and FOIL and then combine like terms. So that's what we're going to do now. And our goal here is to get to standard form so that we can then find the vertex, which means that we're going to do the x-coordinate equal to what? Do you know that formula yet? Have you memorized it? Negative b over 2a will get you the x-coordinate, and then we'll find the y-coordinate of our vertex by plugging x in. Okay? X into the equation. Alright, so we're going to start by foiling here. When you take x plus 6 quantity squared and FOIL it, you should get x times x is x squared. You get the outside inside of 6x and another 6x, that's 12x. This is stuff from chapter 6. If it's still tripping you up, please get some extra help. Last times last is 6 times 6 is 36. So what I'm doing here behind the scenes in my mind, x plus 6 times x plus 6. That's what's happening, and I'm foiling that out. Then I have my minus 5, of course, that's written right here. So foiling, and then we're going to combine like terms. And so it's the 36 minus 5, that will get you y equals x squared plus 12x plus 31. And from there, we recognize that we are in standard form now, so we're going to look at our a value is 1, positive 1, our b value is positive 12, our c value is 31. And to get the x coordinate of our vertex, we do our negative b over 2a. So we've got negative b over 2a. In this case, our b is positive 12, our a is 1, so that gives us negative 12 over 2, or just negative 6. Okay, so that is our x-coordinate here. We'll just kind of highlight it for ourselves. And now we're going to find the y-coordinate of the vertex. We plug x in and solve. So we've got y equals x squared plus 12x plus 31, and we're going to take that x coordinate and plug it in, negative 6. And that will give us y equals negative 6 squared is positive 36. 12 times negative 6 is a negative 72, or subtracting 72, and we still have our plus 31. And when you start to combine all that, 36 minus 72 is a negative 36, plus 31, you get a y value of negative 5. So there is our y coordinate here. So our vertex is going to be the point negative 6, negative 5. Okay? So, and that's what they asked to do, is find the vertex. We aren't graphing right now, we're just looking at the vertex. Let's do that again with number 44. Now, what's different about this one? Always pause and kind of as your assignment goes along, the problems do kind of step up. They get a little harder as you go. They get more involved, more complicated. But the good news is the steps don't change. What you're going to do doesn't really change. The concept doesn't change. You're just being exposed to more of what you could see. So in this case, what's different? Well, Instead of just having the parentheses squared, you've got a number multiplied on the outside. Well, get this. Back over here, you had a number multiplied on the outside. It was a 1. Okay? So it's not going to change that at all. You're just going to, and now you're going to FOIL, just like you did before. Here, shall we draw the curtain for some privacy? FOIL, then distribute that -3, then combine like terms. So let's do that. So when we FOIL this out, x plus 4 quantity squared, we're going to get y equals that -3 still sitting out there. X squared, 4x and 4x is 8x. 4 times 4 is 16. Notice that plus 6 is just kind of hanging out there as well. That just comes down. All we did was FOIL here. The -3 still comes down. That's all that's changed. And then let's go ahead and distribute that -3 across there, because again we're trying to get it all the way to ax squared bx plus c, that these are 3 standalone terms. They don't stand alone right now, they're being multiplied by the -3, but we're almost there. Y equals -3x squared. -3 times 8 is going to be a -24x. -3 times 16 is going to be a -48, and then we still have the plus 6. So our final version here is y equals -3x squared minus 24x. -48 plus 6 is going to be a -42. Alright, now we're in a standard form. I can go ahead and identify my A, B, and C values. I'm just going to note that on the previous example of where we were. We were at standard form right there. So our A value in this case on number 44, A value is that whole number in front of the x squared, -3. Our B value is the entire number plus the sign, keep those signs, in front of the x, -24. Our C value is -42. And then to come up with the x coordinate of the vertex. Hope we're memorizing that formula. I'm telling you, it breaks my little heart when we work so hard and you guys just really put your effort forward. You learn that quadratic formula, do all that, and then you lose sight of the fact that you need to memorize this x coordinate. How to find the x coordinate? -b over 2a. -b over 2 times a. So write it out, say it, whatever it takes to get that in there. So there's our b value and our a value, -24. I take the entire b value, including that -24, put it in the formula. The formula is then going to take the negative of the -24. Take that entire a value of -3, put it on the bottom of that formula, and then it's going to get multiplied by -2. And in this case, it's going to give us +24 over -6, which works out to -4. So we're going to just highlight that. That is our x coordinate of our vertex. We don't want that to get lost in the shuffle there. And now we're going to go after the y coordinate of the vertex. How do we do that? Well, we plug x in. Ooh, lost my ability to write readable letters there. Plug x in. And so I'm at y equals, where are we? Here's our standard form. So y, actually it could probably be safe, super safe to plug it back in the original, but I'll keep it here for now. Y equals -4. Although I'm liking plugging it back into the original. Oh well. Either way, original or the other. Maybe since I did this one back into the standard form, I'll do this one back into the original. So I'll make note of that. It can go into the original, or if you're really confident about your version of the standard form that you rearranged it to, that's fine as well. So let's put it back in the original in this case. Got x plus 4, the whole thing squared, plus 6. So we're going to take that -4, plop it right in here. Because a nice thing happens, at least for the arithmetic here, -4 plus 4 is just going to give us 0. So y equals -3 0 squared plus 6. 0 squared is just 0, so that's negative 3 times 0. That's just 0. Add the 6, I just get an answer of 6 there. So the zeros just keep falling out, and I get an answer of 6. So my vertex here is going to be, I have the negative 4, positive 6. Okay, let's see how I did camera-wise. Yeah. Squeaked by here. I think what shows on my camera screen gets a little cut off when you see it pulled up on the computer, so I'll give it a little extra room there. Now, here's what I'd like you to notice before you get a chance to try it. I want you to look at the final answers of our vertex, negative 6, negative 5, and over here, negative 4, 6. And I want you to compare it back to the version of the equation that they gave us. So when we had quantity x plus 6 squared minus 5, we got a vertex of negative 6, negative 5. When we had negative 3x plus 4 quantity squared plus 6, we got a vertex of negative 4, 6. Any thoughts? What do you notice? Let's use our powers of observation here. Well, did you notice that the y value of the vertex equaled that value that was hanging out here? It wasn't a coincidence. That will happen every time when it's in this kind of format that they give it to you. Now, what else do you notice? Is there any other relationship? The negative 6, it's a positive 6 inside here. Became a negative 6 on the vertex. It's a positive 4 in here, it becomes a negative 4. So notice that when it's in this form, or this format, the vertex is the opposite of the what's with the x, the value of the x in that x squared piece, and then this extra piece out here, the y coordinate, is the extra that's hanging out up here. So when we come back and you get to try this in the next little video segment, I'll spend some time on the bottom of the page kind of investigating this with you a little bit.